Good morning, sir. My name is G. Kiran Kumar. My name is G. Kiran Kumar. I am from ECE Section B and my roll number is 2195180473. And my topic is application of the Laplace transformation in the solution of linear integral equations. Abstract. Integral equations are defined and reference are given to the Laplace transform technique. Most of the operations are used illustrated through a solution of Abel integral equation. It is shown that the Liouville-Newmanian series follows logically from an operation solution of Polteros integrated of the second kind Whittaker obtained solution to the integral equation with the kernel expressed in the last three forms. His procedure was quite involved, and it is shown here that the sample solutions are obtained more directly through the operational calculus based on the Laplace transform. The first kind linear electron integral equation is given by where the where the unknown function that will be determined occurs only inside the integral sign. The kernel and the function are given real valued functions, a Laplace transformation of function. The Laplace transformation of the function f of t for exists if f of t is spacious, continuous and exponential order, that these conditions are only sufficient order for the extension of Laplace transformation of the function f of t. Integral transformation have wide applications in the variable disciplines of engineering and science to solve problems of hot transfer spin, mixing problem, electrical networks, bending of beams, carbon dating problems, Newton's second law of motion, signal processing, explosion, growth and decay problems in the advanced. Time research are increased in shown the advanced problems of research, science, space, engineering and real life by introducing new integral technique forms. Linearist equation developed. Agarwal at 1 gave the application of Laplace transform for solving population growth and decay problems. Agarwal each at 2 discussed the application of Laplace transform for solving improper integrals was integrated consisting of a function Agarwal, Sharma and Chauhan 3 to 10 used different integral transform. Kamal transform, Mahagob transform, Mahan transform, Apu transform and Elzaki transform and solved Volterra integral equations of first and second kinds Agarwal et al. Let us see some of the examples of Laplace transform of some elementary functions. Table 1. First one, f of t. L of f of t is equal to h of a. If 1 f of t is equal to 1, then L of f of t is equal to 1 by v. If f of t is equal to t, 1 by v square. If f of t is equal to t square, L of f of t is equal to 2 factorial by v cube. If f of t is equal to t power n and n belongs to n factorial by v power n plus 1. If f of t is equal to t power n greater than minus 1, rho of n plus 1 by v power n plus 1. F of t is equal to e power at, then 1 by v minus a. f of t is equal to sin a t, L of f of t is equal to a by v square plus a square. Cos a t, if f of t is equal to cos a t, then v by v square plus a square. If f of t is equal to sin a by b square minus a square. If f of t is equal to cos hat, v by v square minus a square. And here is the, let us see some more examples of table to inverse. It is the inverse Laplace transform of some elementary functions. If h of v is equal to, if h of v, then f of t is equal to L inverse of h of v. If h of v is equal to 1 by v, then Laplace inverse Laplace is converted into 1. If h of v is equal to 1 by v square, it converts into t. If h of v is equal to 1 by v cube, then t square by 2 factorial. If 1 by v power n plus 1, n belongs to n, then t power n by n factorial. If h of v is equal to 1 by v power n plus 1, n greater than minus 1, then t power n by rho n plus 1. H of v is equal to 1 by v minus a, then f of t is equal to e power e t. If h of v is equal to 1 by v square plus a square, then f of t is equal to sin a t by a. If h of v is equal to 1 by v square plus a square, then it is sin a t by a. If h of v is equal to v by v square plus a square, then it is f of t is equal to cos a t. If h of v is equal to 1 by v square minus a square, f of t is equal to sin a t by a. If h of v is equal to v by v square minus a square, then f of t is equal to L inverse of cos h a t. Conclusion. In this paper, we have successfully discussed the Laplace transformation for the solution of first kind linear Volterra integral equation. Then given application shown that the exact solution have been obtained using very less computational work and spending very little time. In future, the proposed scheme can be applied for other linear vertical integral equations and their system. Here is the reference. I took the reference from the Agarwal S. Gupta A of Scientific Italian application. And thank you.